Oh, okay. I ain't got nothing. Although the way my brain works, halfway through one of these questions, I'll probably think of one, then I'll have to tell you, or else it'll distract me. Okay, so I'm kind of going to stick to the same format. I'm going to start off with a question that some of you had issues with. It's a homework question. After that, we'll really throw it open to you, and we'll go whichever way things end up going. I'm going to change this over. Right. This is the question that we're being asked to solve. Solve sine of x equals 0.2, and x is going to be between 3 pi and negative 3 pi, right? So you recollect a question that looked something like that. Now, they gave you a picture. And you were trying to solve the places where that straight line, a height of 0.2, meets up with the sine function. And I believe there's 6 answers, 6 solutions, and you had to write them all down, and it had to be to 4 decimal places. So let's look at how do you use your TI-84, or in my case, the TI-84 emulator, to solve trig equations where the angles are not on the unit circle. You will not find a y coordinate of 0.2 on any of the angles in the unit circle, right? You kind of know what the unit circle numbers are, right? They're a half, there's root 2 upon 2, there's root 3 upon 2. You've seen them, so you just know them now. So what I'm going to do is I'm going to get the calculator to do that same question. So it's basically let the calculator do all the hard work. First thing you do is you make sure that you are in radians, because that's what this question was. Then what you do is you go and you hit y equals, and I'll clear these guys out, and you type in sine x, and then you type, oops, let me do that again. And then you type in on a separate line 0.2. So sine x equals 0.2 becomes 2 distinct graphs. You then go to your window, and in this question, they wanted negative 3 pi to positive 3 pi. So x min is negative 3 pi, and x max is positive 3 pi. And then I choose the zoom window, and I always like zoom 0. It's way down here, but if you just say zoom 0, it's zoom to fit. Now, can you see that you've got everything in that picture, at least visually? And what you're trying to do is you're trying to find out where the blue sine function is equal to the red straight line 0.2. And there's an answer here. And so we're looking for that x value. There's the second, there's the third, fourth, fifth, and lastly the sixth. So there are 6 solutions. Each one gets its own little box in the homework to 4 decimal places. Now, if you use this graph, there's no way in Earth you're ever going to be able to estimate any of these x coordinates. See that guy there? There's no way in the world you're going to be able to measure that, read it off to 4 decimal places. So the book was a little bit unfair the way they phrased it. What we are going to do is let the calculator find it. So I'm going to go second calc. And the guy I'm choosing is number 5. I'm going to hit intersect. Now, it asks for the first curve. I'm just going to do move my cursor around a little bit. I'm going to move my cursor close to this one, because that's the one I'm going to get. Eventually, I'm going to have to get all of them, but let's say that's the one I want just right now, this one here. Right, so you got, it says first curve. Do you notice that it's on the blue curve? And yep, that is my first curve, so I'll hit enter. Have you noticed now that it's jumped to the second curve, the little straight line guy? And is that my second curve? Yes, it is. So I'm going to hit enter. And then it says guess. Well, as I move my little cursor around, do you see that I can move to anybody. So for instance, see if I went and entered here, it would tell me that solution. If I went a little bit closer, I think, if I went, say, here, do you see it would get me that solution? The one I've decided I want is the one over here. So just pick something relatively close and then hit enter. And the answer that you get in this particular case is negative 3.3430 to 4 decimal places. That makes sense? So you're going to use your calculator to solve a trig equation. So you don't need a unit circle. You don't need to do any algebra at all. First guy equals second. Let's look at the second situation. Let's suppose I had the sine of x and I wanted to find out when it was equal to the cosine of 2x. So can you imagine the question was to 4 decimal places, give me all the solutions to sine x equals cosine 2x, and only pick numbers from 0 to 2 pi, for instance. So I'll go back to my window, and since I'm only picking numbers now in this question from 0 to 2 pi, do you see how I changed my x min to 0 and my x max to 2 pi? And then when I do my zoom 0, I'll see a picture. And there's an answer there. There's a second one there. It looks to me like there's a third one there. So in this case, it'd be 3 solutions, right? Let's pick that one in the middle. Let's suppose I want to know what he is, right? That guy there. Second calc, option 5. Intersect. Now, I'll move it a little bit. It's on the first curve, the blue curve, correct. As you see, it's now jumped to the second curve, the red one, correct. I want to guess about there, enter. And the answer is 2.6180 to 4 decimal places. So can you see that if the answer is not a unit circle answer, right, an angle that you cannot get from a unit circle, your only other alternative for these type of questions is to put them into your calculator, right, and just read off answers. So in a lot of ways, it's easy because you don't need to do any algebra, don't you? Just need to know how to press right buttons in your calculator and where to find the answer, and you call it good. So that is our example of that particular kind of question. I'm going to stop the share and go back to this fella. Has anybody got a homework question they want me to do next? Because it looks like I got a chat question. Right, this is for Daria. She said, he says, I think there's a problem with set 2. I'm doing problem 4 and it won't let me finish the 4th step. I've had that brought up to me before. I do not know why it doesn't do that, but I will give you the points for doing it as long as you can send me a scan of the working. So I know that is true. And my next question in my list is, we're going to go over number 9 from 4. I don't think it's 4-6. Do you mean 4-5 probably? Or 4-4? Conrad, which number 9 are we talking about here? Because we don't have a 4-6. Oh. Conrad? Okay, 4-4. We are good. Right. I'm going to have to go in and look at that one because I don't know what the question is, and it's probably quite hard for him to type it. So if you can bear with me for a second, we'll go in and have a look at that guy. And it's question 9 from 4-4. Why can't a skeleton go to the prom?
Why not?
Because he's got no body to dance with. Oh God, I've just thought of a really, really bad joke. But let's get this thing set up before I forget my job, which is right. Number 9. I believe you can tell me in a few seconds whether or not this is the case. That we're being asked to solve this question, and they want you to do it in the format. This is a little bit weird in that format. Is that the question that you are talking about that you want me to do, Conrad? Yes, okay, we are good. Now, show you this question. This theta plus pi k is a bit unfortunate because the variable's called x, so it really should be called x plus pi k, but that's me just nitpicking. If I want to solve 8 sine x equals 3 cosine x, which is essentially what we've got here, I'm going to try and solve it by simply just rewriting it in a format that makes more sense to me. Do you know there's a rule that's called, as long as you do it to both sides, it's okay rule? That's my name for it, right? That's how you solve equations, right? You know how you add 2 to both sides or you divide both sides by 4, right? That's what that rule's all about. So I'm going to take this, and I'm going to divide both sides by cosine x, which means that this fella here becomes 3. What does 8 sine x over cosine x become?
8 tan.
So we're now looking at 8 tan equals 3. Wait a minute, doesn't that make tan x 3/8? Are we good? Divide both sides by 8, so tangent of x is now 3/8. Now, to find x then, don't I just need to find the inverse tangent of 3/8? So what I'm going to do now is I'm going to go to my calculator and clear that out of the way. And I'm going to go inverse tan of 3/8. Not in the unit circle. If it was in the unit circle, I'd be going to the unit circle right now and I'd be saying pi upon 3 or something, right? But I know 3/8 isn't in the unit circle. So it's going to be a weird decimal. And it's going to be the weird decimal, 0.35. Let's say it's to 3 decimal places. So 0.358, 359. Are we okay so far about how I've got to this point that I found the missing angle? Now, what is the period of tangent x?
Pi k.
Pi, yeah.
Pi.
And the rule is the angle that you got plus period times k. Now I'm writing it as period times k because see if that was a sine x, wouldn't it be 2 pi k? And if it's a tangent x, it's going to be pi k. And later on, you'll see in other situations, it's going to be a half pi k and various other things. So our answer is 0.359 plus pi k, x equals, and we are done. And that really bad joke has now disappeared from my head. So you are lucky. You survived that bullet.
Wait, so I got a question. So
Yes.
did it say on the question itself that the period was going to be pi? Just out of curiosity, or was there
it did actually.
Okay.
Let me share the screen where that question I believe came from.
I just wanted to make sure I didn't miss
Right.
like. Oh, yeah, there
Yeah,
it is.
there it is there. Do you see it there?
Yes, I do.
Right.
Okay.
Now, you've got to be careful about that because there's going to be questions later on where they'll phrase it the same way, but it won't be pi k. They will phrase the sign questions the same way, but they won't say give it in the form 0 plus 2 pi k. Will you just think of that as being angle plus period times k, so that you can adapt it to each situation as it arises? This time it is pi and they're telling the truth, but sometimes they do it with a sine function, in which case they should say 2 pi k, but they won't. And in other cases, the period's going to be a half, and they won't even use that. So think of that as a placeholder for angle plus period times k. And that'll save you getting too caught up with some of the issues that come with that.
Okay, so since the period is pi, if the number that we get, the 0.359,
Yeah.
you would add pi to that number,
And that would get you an answer.
That would give you the second largest.
And then you'd add 2 pi to get a third one, and then 3 pi to get the next one. In fact, in this case, when I'm looking at it, can you see that 358 is my first answer? Okay, they had a lot more decimal places, but that's the same guy I've got. If you add pi to it, can you trust me you get this guy here? Now, what happens if you add another one? Well, you will get an answer, but it will be bigger than 6.28, which is what 2 pi is. So that means no more, no more. So none and none. I can imagine a question where you might get 3 answers before you reach too big, right? Or even 4, I guess, occasionally. So you just have to take it on face value. Sometimes you'll get 1, 2, 3, or 4 answers. Because typically, don't they move these 8s and 3s around? Your question might have 6 sines and 7 cosines, right? In which case you may get more or less angles because of that. Are we good?
Yeah, well, so is the reason why, like on the part A, where it says find all the solutions, that you just stick with the main first answer you get and not add the pi for the second larger value? Like,
I'm not sure what your question is.
Sorry, so like for the part A on this question that's showing on the screen, why is it that you want to put for the larger theta value? Why wouldn't you put the 3.50, whatever? That's down on the second.
Oh, why didn't you put this one?
Yeah, I think I'm just curious why you want to do that. Or is that just what design?
It's a very good question because technically speaking, the next angle would have been 3.5 radians, and that would have been the larger one, right?
Right.
I can't answer that question because I'm not sure what they were wanting. Evidently, they don't want it, so they said none. But technically speaking, there's it makes more sense, this question, when it's not a tangent. You know how when you do a sine function, you'll get maybe an angle in the first quadrant, that'll be the small one, and then you'll get another angle in the second quadrant, that'll be the larger. In those cases, those 2 angles are important because they are different from each other and they do generate different solutions. So in that situation, I can understand why you need that. And the tangent's a little bit different. If you add pi to this, you get the 3.5 guy. But doesn't this answer already have the 3.5 guy in it? I've now answered my question. Right. Imagine you just answered that question, asked that question. Why is that none? Here goes. If you add pi to this number, the answer you get is 3.5. You don't need this guy because all the answers are included in the first one.
Gotcha. Okay.
So that was the reason. For sines and cosines, you will use both, right? But for a tangent, it's not uncommon that only one of them is necessary because when you add the period, you get all the other guys anyway. Have we got another homework question or shall I choose one? Just check on the chat. Sometimes we have here. I think I've answered your question, Daria, did I? How did we figure out the other values with decimals?
I don't think that was the same one. I think that
No?
was.
Oh, okay, do we have a new question? What were you asking again, Daria?
Yeah, it's like, well, it's like a general question. It's like if we're like dealing with decimals, kind of similar to the one that we just went to. How do we like find the other
Decimals.
decimals?
Okay,
Or,
let's pretend I did a question, right? And the answer ends up being nothing 0.123, right?
yeah.
And we know that we've done the other bit and it ends up being pi k, right?
Yeah.
Okay, right. If you want to get the next one, you add pi. Well, pi is on your calculator, but roughly it's 3.1412. So you just add them together in the usual way. And you would get, what would you get? 2, 4, 6, 2.
I thought isn't there like a different way to do it with sine and cosines?
Well, when it's sines, you add 2 pi. And when it's cosines, you add 2 pi k.
Oh, okay. Because I thought like you just like subtract the like pi.
Oh, we're looking at, I know what you're talking about. Okay.
Yeah, I was like,
Right, let me show you that question then. That's not connected to this one, but I know what you're getting at, I believe. It only really works, or it's only a problem with sines and cosines. Tangents, it works fine, because the one answer you get is the one you're going to use, right? But for a sine, there's 2 answers, but the calculator only gives you 1. So let's go hunting for that next angle. Let's suppose I end up with a question that I need to solve that. Well, that means I'm going to find the inverse sine of 0.234. And I'm going to have to zoom over to my calculator. I won't do the share thing. I'm just going to get an answer, and you're just hopefully going to trust me on this. So the inverse sine of 0.234. And the answer oh, darn it, that's a freak. The answer I get is 0.236. Virtually the same number, sheer coincidence, right? So far, so good?
yeah.
Right, so if you imagine that your first answer, because it is positive, I know it's in the first quadrant, can you imagine that this angle is 0.234 radians? It's much easier to imagine it if it was 42 degrees, right? But can you imagine that angle is 0.234 radians?
Okay.
Since the sign is positive, what other quadrant do you get a positive sign in?
The second quadrant.
So what you then have to imagine doing is you draw another guy over here, and this angle here is called the reference angle. And this angle in here is the angle that you make with the x-axis. It's called the reference angle. And it will also be 0.234. So I'm going to write my first question down here. There's the first one. Gotcha. Now, how do you find the second one? Its reference angle is 0.234, but the one that we want is this angle, right? So if I know this is 0.234 and I want to find this angle, what do I need to do? Well, pi take away 0.234. I don't know where my 4s came from. It's a 6. 236. And you might say, why pi? Isn't the whole start to finish, isn't that pi? And if this bit is 0.234, isn't the bit that's left pi, take away this guy? So the other answer is going to be 3.1412, take away this fella, and the second answer ends up being whatever the difference between those two are, So I'm going to type that in and see what it is. It's 3.141 subtract 0.234. And so I get 2.907.
Okay.
So that's a different question, or a different thing than what we just did, right? That is, find the two angles that you need in a sine or a cosine question where it's a decimal and you had to use your calculator. The one we just finished was really find the only one angle for the tangent that you need to find, in which case you didn't have a problem with the other one because you don't need to worry about it at all, because you just add pi's to it until you get them all.
Can I see that picture one more time? Just a little flash of it, sorry.
Sure, I'll put it there for a few.
Okay.
Are we good? Right, while she's doing that.
Yeah, that's good.
Okay. Has anyone got another homework question or question in general?
Someone has a question for, like, a general question in the chat.
Sure.
In the chat.
Okay, let me check it out. Okay, so what we're going to look at now is an example of solving a trig equation that involves factoring. So I'll make up one with a 7 in it. Yeah. 7's not a nice number. Okay. Suppose you were trying to solve this trig equation. These trig equations are going to be solved by factoring. If I went and said to you, I want you to solve y squared, take away 8y plus 7 equals 0, right? A kind of question that you might have got when you were in, what, Math 99 perhaps, right? Wouldn't you have to factor the quadratic? And the rules for factoring don't change. Two numbers that multiply together that give me plus 7. But when you combine them, you get negative 8. What two numbers does that job? Well, just, I guess, sorry.
Oh, sorry, go. Sorry, would it be -1 and -7?
Yes.
-7 and 1.
Yeah, whatever way you like, they're both correct. So, yeah, there are not a lot of choices with 7, so maybe the fact there's not a lot of choices throws you, because a lot of people forget the 1 times the number choice. You know, when it's 16, you're thinking of 8 and 2 and 4 and 4, and, you know, you forget about the 1 and 16. Right. Now, can we double check that? Yeah, don't they multiply together and give you plus 7, but when you FOIL it out, you get negative 8? Now, this question up here might not look like this, but essentially it is. It's a quadratic. You might, I don't know, it doesn't help me, but it might help you. If you imagine that the question was written like that. Do you know cos squared x just is our convenience of saying cos x being squared? So that's like y squared, take away 8y plus 7. So that means I should be able to factor it. It's going to be cos x subtract 1, cos x subtract 7 equals 0. Put a little bubble around this so it doesn't distract me. Now, once you've factored things, can't you then use the factors to solve the equation? For instance, in this case here, wouldn't you get y equals 1? And the other choice would be y equals 7. So the two solutions would be y equals 7, y equals 1. We're going to use that to help us get the solution. For instance, this one here, we are trying to solve, and we end up that it's going to work when the cosine of x is equal to 1. Well, that's not too hard to do. I mean, if you think about the cosine of x being equal to 1, where do you get the cosine x? Well, how about it's 0, agreed? Is there anywhere else that the cosine of x is equal to 1?
No.
No.
Just that one.
Well, yeah, but I guess if I phrase the question better, doesn't it end up being 1 at 2 pi again later on? And then 4 pi, and then 6 pi, and then 202 pi. So it depends on what's going on over here. If the question was phrased like this, then wouldn't my answer be 2 answers, 2 solutions? Right? If the question didn't have that, in other words, you're going to do the 2 pi k version, right? You know, the version with all the 2 pi stuff in it. Then wouldn't I just say 0 plus 2 pi k? Do I need to write 2 pi down now? Isn't 2 pi just a particular version of this 0 plus 2 pi k? It's 0 plus 2 pi. So that would be your solution. What about this fella? That's a weird one. Can you think any angle that has a cosine equal to 7?
No.
I cannot.
And nobody should be able to, which means you don't get anything from that one, which means all your answers are in here.
Is it like the limits of the inverse of cosine 0 to -1, or is it, or am I just thinking about something else?
No, you're right. Yeah, the inverse cosine function only takes values from -1 to 1, right?
Oh, okay. -1
right?
to 1. Yeah.
And to me, I visualize the cosine. If I draw the cosine, doesn't it only give as high as 1 and only goes as low as -1, right? Cosine x on its own can't be bigger than 1 or less than -1. So that's how I kind of say, yeah, you're not getting anything out of that. Okay. Right. So I've got 7-4 number 1, question 10. Okay. So 7-4, set 1, number 10. And let's see if I can first find that guy. So set 1. View question 10. It must be close to the end. Yeah, it was. Okay. So I'm going to share the screen to show you what question 10 looks like. And then we're going to, pardon me for the pausing. There, okay. Should be sharing that screen. So this is what question 10 looks like. You have a function called sine of 2x. You have another function called 2 sine 2x plus 1. And it's got the graphs of them. And I mean, if you really were thinking about it, couldn't you just plug them into your calculator and have a look at the picture and see which one matches the picture? You know, adjust the window a little bit and you could do it that way. The part that's probably going to cause you the trouble is find the points of intersection in the interval 0 to 2 pi. So I am looking at least in my question, I'm looking at the sine of 2x and then 2 times the sine of 2x plus 1. Okay. They want to know when two things intersect. Do you know they intersect when they're equal to each other? So when does this line meet up with that line? You set the first line equal to the second, the equations, and solve. Now I'm just going to write this a little bit more horizontally. There we go. Now, as long as you do it to both sides, it's okay, roll. Give me something to do to both sides.
Subtract 1.
Sounds like a good plan. There are different approaches to this, but subtract 1 will work. As long as you do the next thing. So what do I do now? I don't want this in two places, don't I? Don't I want the sine of 2x's just to be in one place? So if I can add 5 to both sides or take away 1 from both sides, shouldn't I be able to subtract sine of 2x from both sides? I don't care what it is as long as I do it to both sides, right? So I'm going to subtract the sine of 2x from both sides and take 1 away from that. Now leaves me with the sine of 2x. So far, so good. Now, side issue, because it's going to be important later. What is the period of the sine of 2x? I know the period of sine x is 2 pi, but the period of sine of 2x is not 2 pi. Can you remember the calculation that you would do to find the period? You might actually just know it in your head, but can you remember the calculation?
2 pi.
It's pi, isn't it?
Yeah, it's going to be pi. So it's 2 pi divided by the coefficient of x, which is, as someone said, is pi. Okay, now, hold on to that thought. He's going to come in later, right? Back to this question. There is no reason for me to do this except it bugs me. For some reason, my brain likes sine 2x equals -1 rather than -1 equals sine of 2x. You agree it's the same thing, it's just cosmetic. Right. Don't worry about the 2x. Think of that as a placeholder. The sine of an angle is -1. On your unit circle then, aren't you looking for a y-coordinate of -1? What kind of angle then does that work for? Because there's only one of them. Typically there's two, but in this case there's only one.
Only one?
Yeah, well there's only one place where the sine function is equal to -1.
3 pi over 2.
Agreed, 270 degrees. So we are looking at 3 pi over 2.
Oh.
Now, normally, normally there's two answers, right? There's a 30 degree and 150, you know, something like that. But that's a special case. There's a couple of special cases, and that's one of them. Now, I said the sine of some angle, right? That some angle happens to be 2x. So that makes 2x equal this guy. Now we go back to as long as you do it to both sides, it's okay rule. What do you do to both sides?
Divide
Get
by.
it?
Wait, how did you get 3 over 2 pi again? Sorry.
If, yeah, you are looking for an angle whose sine is equal to -1, and the angle that does that, and I don't want to call it x, I want to call it angle,
Oh, I see. Okay.
is that guy, right? Now, we are looking good. The solution is 3/4 pi. And that's nothing wrong with that. It's an answer. But we want all the answers, I'm assuming.
Yeah.
And the generic version of all the answers is 3/4 pi plus the period k. Not 2 pi k, although a lot of the time it is. Period k, right? What's the period of this sine 2x that we've been dealing with today?
Pi.
So that is why that answer is going to have a pi k. Can you imagine it was the sine of 4x or the cosine of 3x, right? Something like that. Wouldn't the period in those cases also change? And so you'd get the answer that you're looking for, and then you wouldn't just automatically say, oh, it's a sine function, so it's plus 2 pi k, because it might not just be a sine function. It may be the sine of 2x or the cosine of 5x, and that makes a difference. And so always be on the lookout for the period. If it's a sine x, it's plus 2 pi, right? But when it's not sine x, when it's sine 2x or sine 10x, then that makes it a little bit different. And that's us kind of came to the end. So you want to hear the bad joke that I forgot and remembered?
Absolutely.
God, you are gullible. All right.
Always look forward to them.
Okay. So here it goes. Two Scottish guys were in a bar drinking. And one of them turns around to the other and said, I heard you won the lottery. Is that true? The guy says, yeah.